So in this video today, I'm going to go over the Fall 2024 Geometry Final Exam Review. So this first problem gives us some points, and it says they form a quadrilateral. We got this from Delta Math. It says, plot the points, and you would have to plot the points on your final exam, okay, to figure out what you think the shape is. Then find the desired slopes and lengths, then fill the words that best identify the type of quadrilateral. So I'm going to do this first one, the first two with the slope, and talk you through them. But first of all, how do we find slope? We find slope by doing rise over run. Okay, and how do we find the length of a side? We do that by doing our rise squared plus our run squared, and then we take the square root of that. Okay, so we're going to do this with the first two sides, and then I'm just talking through the rest. Okay, so the first one is TU, so I'm going to go up 1 2 3 4 5 6 7 8 9 10, so 10 up, and 1 2 3 4 over. Okay, now no, that reduces, right? That reduces. They're both divisible by 2, so this is going to be 5 over 2. So that's our slope. And now remember, you always square the original number. So when I do this, I'm going to do 10 squared plus 4 squared, and then take the square root of that. So 10 squared is 100, and 4 squared is 16. So this is going to be the square root of 116. Okay. I'm going to do UV 1, 2, and go over 1, 2, 3, 4, 5. So this is going to be negative 2 over 5. And again, we're going to do it. It doesn't matter whether you square negative 2 or 2, because both of them end up with 4. So that's going to be 2 squared plus 5 squared. That's going to be 4 plus 25, so that's 29. Okay. So you understand the process now. So we're going to do this for all the sides. And so when I did the slope of VW, it was also 10 over 4, which is 5 over 2. And that means, again, this is a square root of 116. Then this next one was negative 2 over 5 again. So this would have been, again, the square root of 29. So looking at the shape, I think it's a rectangle, but we have to prove that, okay? Now, the first part here is we're going to talk about the slope. The next thing is we're going to talk about the slope of TV and UW. These are our diagonals, okay? So I'm going to do this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12. And 1 over. So this is going to be negative 12 over 1. Okay, so 12 squared is 144. 1 squared is 1. So this is going to be the square root of 145. Okay, then we're going to do the other one. And I'm going to erase some stuff here because it's getting busy. So 1, 2, 3, 4, 5, 6, 7, 8. Up, yep. 1, 2, 3, 4, 5, 8, 9. So 8 up, 9 over. So 8 squared is 64, 9 squared is 81. Add those two together, that's going to give us 145 as well. So those are our diagonals. Then it says write some statements about the sides in the diagonals and prove based on the characteristics of the shape. Okay, so we're going to talk about TU. Right there is parallel with what? VW, right? Then WT, notice right here, WT is parallel with what? UV, right? Okay. And the side lengths, TU is equal to WV again, or VW, sorry. And then WT again, notice these two are both the square root of 29, right? So this is also going to be UV. So opposite sides are parallel and congruent. Okay, it says, are there any other sides equal? No. On some shapes there are, like the rectangle and the rhombus, the square and the rhombus, but not a rectangle. It says, are there any sides perpendicular? Well, the answer to that is yes. How do we know? Okay, so look here. We have a 5 over 2 slope there, and we have a negative 2 over 5. So remember, perpendicular slopes, which produce right angles, are going to be reciprocals of each other, and we got 5 over 2 and 2 over 5, and then one's going to be positive, the other's going to be negative. So this is true. So we're going to move right around this shape, and we're going to name them. So we're going to go from T to U, and then U to V, and then V to W. So we're just going to move around the shape and make this statement. So TU is perpendicular with UV is perpendicular with UW is perpendicular with WT. Okay? And then it says, what relationship do the diagonals have? Well, this was our diagonals right here, right? So there's no relationship between the slopes right here, is there? No. But you should notice that the side lengths, or that the lengths of the diagonals are the same. So we can say that TV is equal to UW. And remember, that's one of the characteristics of a rectangle, is that the diagonals are congruent. Now with the rest of these, I'm just gonna tell you the slopes. I'm not gonna actually work them for you. And then we're gonna figure out what relationships are. So when I did this one, it was -7/4. And then I squared those two numbers and I got the square root of 65. This next one was -2/5. And when I squared those, I got that square root of 29 again. Here, another 7/4 and square root of 65. And here, another a -2/5. And again, square root of 29. So based on this, because the side lengths are not all the same, and the only two shapes this would have been a parallelogram or a rhombus, and the sides are not all the same, so I'm going to say it's a parallelogram. So then it's asking us about the diagonals. So we got our MK and our NL, right? So we're going to find the slopes of those again. So this is -9/9, which would be -1. And when we square those two numbers, we get the square root of 162. The other one is -5/1, which would be -5, right? And again, when I square those two numbers, I get the square root of 26, okay? Then it asks us about the characteristics of the shapes. So KL, we see, is parallel with MN, and LM is parallel with KN. And those are also equal, right? MN is equal to KL and LM is equal to KN. And it says, are there any other sides that are equal? The answer is no. And that would be because it would have been a square or a rhombus. Are there any sides perpendicular? The answer again is no. What relationships do the diagonals have? Well, the only relationship the diagonals have in a parallelogram is that they bisect each other. So we could say that MK bisects NL, and also they have the same midpoint, don't they? Those are the characteristics of the diagonals in a parallelogram. All right, this is going to be our fun one because it looks to me like it's a square, right? Okay, so the slope of NO was 6/2, which was 3. 6 squared plus 2 squared is going to be the square root of 40. Okay. Then the slope of the next one is -2/6, which would be -1/3, but that's still the square root of 40, right? Because same two numbers. Again, 6/2, this would be 3, this would be the square root of 40, and then our -2/6, which would be -1/3, again, still square root of 40. So right now, all four sides are equal, and notice that the consecutive sides are also perpendicular, right? So the slope of NP is the diagonal. So that slope was -8/4, which would be -2, right? And the length, when I square those two numbers, is square root of 165. Whereas the slope of the other one was 4/8, which is equal to 1/2. And however, they're the same numbers, right? So this is going to be the square root of 165 again. Then, yes, NO is parallel with PQ. OP again is parallel with QN. And that means that PQ was equal to QN, right? And I'm sorry, NO is equal to PQ and OP is equal to QN. It says, are there any other sides that are equal? Well, in this case, all our sides are equal, right? So we can actually say in this statement that NO is equal to PQ is equal to OP is equal to QN, right? All the sides are equal, okay? And then it says, are there any sides that are perpendicular? So the answer to that again is yes, right? Okay, so we're going to go around the shape like we did before, NO, OP, PQ, QN, because look at these slopes. They are reciprocals of each other. Y'all see that? And negative reciprocals. So we're going to say NO is perpendicular to OP is perpendicular to PQ is perpendicular to QN. And then what relationships do the diagonals have? That was this right here, right? These lengths. And look what else. They are also perpendicular. So this time we're going to say NP is perpendicular to OQ and that NP is equal to OQ, right? Okay. So remember, these are all the types of relationships. Now, diagonals, when their diagonals are perpendicular, that means it's a rhombus. When they're equal, that means it's a rectangle. And remember, a square is a rectangle and a rhombus, right? All the sides are perpendicular, all the sides are equal, okay? So that's a really good one to study. So on this next problem, it says to simplify. So I'm going to write the first one, 7v squared minus 4v, okay? I want to see if there's any matching terms. So I'm going to do this vertically. So I'm going to do my 3v cubed. I don't see another v squared. And then I've got minus 9v, and then I got a plus 5, right? So remember, we're subtracting all this. So we're going to change that sign, we're going to change that sign, we're going to change that sign, okay? So I'm going to bring down my minus 3v cubed, bring this down, plus 7v squared. Now we're going to actually compute this, right? 9v minus 4v is going to be 5v, and then we're going to bring down our negative 5. So that's the answer right there, okay? So the next one is multiplication. So we're going to use a box. So remember, the trick to this is writing things in descending order. So I'm going to take this first one and I'm going to put here 6x squared, 7x, and negative 5. And then I'm going to do the other one the same way, negative x to the third, 4x squared, and negative 8x. Now, because we're doing this, it'll help us see where things line up in our diagonals. So this is going to be in negative times positive is negative, negative 6x to the, remember we add the exponents, fifth, right? Then this is going to be 24x to the fourth. This is going to be negative 48x to the third. This is going to be negative 7x to the fourth. 7 times 4 is 28, x to the third. Negative 8 times 7 is negative 56. X times x is x squared. Negative x times the negative, this is going to be positive, right? So it's going to be 5x to the third. Negative times a positive is a negative, so this is negative 20x squared. And then this is going to be negative times the negative, so this can be positive 40x. Okay, so now, remember, we have like terms in our diagonals here. So those are like terms. These are like terms. And these are like terms, okay? So when we do this, we're just going to add our like terms together, use your calculator, and then come back to me when you're done, and we're going to talk about the answer, okay? So this is negative 6x to the fifth. That was this term right here. When I combine the next two, I get plus 17x to the fourth. And then I get minus 15x to the third, minus 76x, plus 40x. So that's our answer right there. Okay. All right, so the next one says find the perimeter and area. This should remind you a lot of what we did on the performance funnel. Okay, so we have the whole width here, and we have the width of B, and we want to find the width of A. So we're going to take 17x plus 4, and we're going to subtract from it this, the 6x minus 2. Now remember, when we subtract, we got to change the signs of both. So this is minus, and that's now going to be plus, right? So this is going to end up being 17 minus 6 is 11x, and 4 plus 2 is 6. So that's what's going to go back up here on top of A. So this is going to be, excuse me, 11x plus 6, okay? So now we want to find the perimeter of section A and the perimeter of section B, and then the area of both, okay? So to find the perimeter, we're going to go 2 times our length, 2 times our 6x minus 5, and then we're doing plus 2 times our 11x plus 6, because these are our two sides, right? There's one, there's the other, okay? So that's going to be 12x minus 10 plus 22x plus 12. So that's going to be 34, like terms right here, see that? 34x, and then we got negative 10 and 12, so that's going to be plus 2. So that's our answer for our perimeter there. Now when we're looking for area, we're going to do, again, we're going to multiply these two things. So we're going to do our 6x and our minus 5 here. We're going to do our 11x and our 6 there. So this is going to be 66x squared. Remember, x times x is x squared. And then 6 times 6x is 36x. 11x times negative 5 is going to be a negative 55x. And then 6 times negative 5 is going to be negative 30. Remember again that the diagonals have like terms, right? So we're going to combine those. So this is going to be 66x squared minus 19x minus 30. All right, do the next one. Come back to me when you're done. So here again, we're doing 6 times our 6x minus 5 plus, what did I say, 6? 2 times. 2 times the length plus 2 times the width, right? And then we're going to do 2 times our 6x minus 2. So here again, we got our height and our width, right? See it? And the height's over here. So we already found that. So that's 12x minus 10 plus 12x minus 4. So this is going to be 24x minus 14. Okay, so once again, we're going to multiply these. So we're doing our 6x and our minus 5 here. We're doing our 6x and our minus 2 there. So 6x times 6x is 36x squared. This is minus 12x. This is minus 30x. And then negative 2 times negative 5 is positive 10. So here again, we're going to combine some like terms. And our answer is going to be 36x squared. Remember, we're combining these right here. So it's going to be minus 42x plus 10. And those were our answers there. Okay, so remember, this says Sarah has a frame she wants to use on a painting. The measurements for the outside of the frame are given. The frame itself will be 2 inches wide on all sides. Using the diagram, calculate the area that will show the painting. Okay, so we want to know this, and we have all of this. Okay, so what do we have to do? We have to subtract 2 from the top and the bottom. So this would be 4x plus 7 minus 4. So that's going to be 4x plus 3. That's going to be our height, right? And then here's our base. That's what we want, just the area inside there. This is the whole width, right? But again, it's got 2 over here and 2 over here. So we're going to do 6x minus 1 minus 4 again. So this is going to be 6x minus 5. So we're going to go ahead and put these two values on our in our box. 4x and 3 and 6x and minus 5. So this is going to be 24x squared minus 12. Whoop, not 12. Can't read my own handwriting now. Minus 20. X, this is going to be 18x, and then negative 5 times 3 would be negative 15. Again, got our like terms right here, so this is going to be 24x squared minus 2x minus 15. Okay? And we've seen problems like all these on final exams, and that's why we got them here, guys. Okay? So this says determine the area of the shaded region. So doesn't that mean we have to find the area of the blue and then subtract from it the area of the white? So I'm going to go ahead and do the area of the white. I'm going to multiply 3x times x plus 2. 3x times x would be 3x squared. 3x times 2 would be 6x, right? So that's going to be the area of the white. Then we're going to find the area of the blue, and we're going to do this with our box. So I'm going to do x and 21 over here, and 5x and minus 4 there. This is going to be 5x squared minus 4x there. This is going to be 105x, and that's going to be negative 84. So once again, we have some like terms right there. So we're going to have 5x squared plus 101x minus 84. And then once again, we're going to subtract this, right? So we're going to subtract 3x squared, and we're going to subtract the 6x. So when we do that, we get 2x squared plus 95x minus 84. So that is the area of just the blue, the shaded. These are our transformation rules, and hopefully you remember these. Reflection over x, we change the sign of y. So this is x comma negative y. Reflection over y is negative xy. When we reflect over y equals x, we flip them. So this, instead of being xy, it's going to be yx. And when it's a reflection over y equals negative x, it's going to be negative y comma negative x. When we scale, remember this was on our last quiz, so when we scale, that scale factor was 3 over 2, so we multiplied it by both things. So here we're just multiplying k times x and k times y. So this next one, I want you guys to put a star next to it because you need to notice the words, okay? So it says translation up 3. So up 3 means y plus 2, right? Left 3 means yx minus 3, okay? So notice the words, okay, in their order, because that's not normal for us, right? So you got to really read, because we've seen this happen on finals in the past, and we've done it to y'all too, but you guys need to really make sure you're reading stuff and don't do things out of habit, okay? Then we got the 90-270 rotation. That's going to be negative y comma x. This is negative x, 180, negative y. And this one is y negative x, okay? All right, number 9 says use the images shown to answer A through C. So remember, we use a tool here, right? We're going to connect all our vertices here. And notice they are all parallel, right? But they are not all the same length. So we are going to bisect them to find our line of reflection. That right there's our line of reflection, and that line is y equals negative x. It's falling, right? So what is the transformation? And remember, if those lines had all been the same, that would have been a translation. So this is a reflection over y equals negative x. Then it says if LM is 4.5, what is the length of L prime M prime? So right there is LM and there's L prime M prime. It wouldn't change, right? So L prime M prime is also 4.5. Remember, the only time something changes is when it's a dilation as far as sides are concerned. And even with angles don't change even with it if it is a dilation, okay? So here it says if angle N was 120, then angle n's then the new n is going to still be 20. So the measure of n prime is also still going to be 120 because angles don't dilate ever, okay? All right, this next one says the rectangle below is rotated 180 degrees clockwise. Now, clockwise, counterclockwise, doesn't matter, right? We know that the rule for that is negative x comma negative y. So what we're going to do is it says which following ordered pairs of vertex of the rectangle's image. So we're going to start with this one right here, and this point is 4, 5. So that means it would be negative 4, negative 5. Do you see that up there? Not me either. Okay. So we're going to go to this one. This is 4, 1, which means it would be negative 4, negative 1. Do you see that one up there? Me too, right there. So we're done. So number 11 says, what are the coordinates of RST with points RST when rotated 270 after reflecting the image over the y-axis? So what's the most important word in this problem? It's that word after. Because what that means is that reflection over the y-axis happened first, and that rule is negative x comma y, right? And then we rotated 270, right? So that rule is y comma negative x. Okay, so we're going to go ahead and write our points here. R is 3, 5. S is 2, negative 1. And T is 1 comma negative 2. Okay, so we're going to apply these rules. So the rule for R prime is going to be, we just change the sign of that x, right? So that's going to be negative 3 comma 5. Then when we apply the next rule, we're going to flip them. So it's going to be 5 comma negative 3, and then we're going to change that sign, okay? So that's going to end up being positive. So we're going to do this for all of them. So S prime, again, this would be negative 2, negative 1, right? And then when we flip it, R double prime, or sorry, S double prime. Wow, look at me. S double prime, so that's going to end up being... we're just going to move them first, negative 1, negative 2, then again we're going to change that sign. See it? I flip them first and then I change the sign. Okay, T prime, wow, some problems with my colors, y'all. T prime is going to be negative 1 comma negative 2, right? And then when we do our T double prime, we're going to flip them, negative 2, negative 1, and we're going to change that to be positive, okay? All right, the next one says dilate ABC on the coordinate plane using the origin as the center of dilation, and then this is our scale factor. See that, 3 over 2? So all we're going to do here is we're going to multiply 3 over 2 times each of the points. So we're going to put A here. That's going to be 2 comma negative 4. Then we're going to do B is going to be negative 4. What is that? Negative 3. And then C is 1 comma 0. Okay, so what we're going to do with this, we're going to multiply 2/3 times, so A prime is going to be 2 times 2/3 comma negative 4 times 2/3, right? Okay, so we're going to do that and we're going to find our A prime. So that's going to be, A prime is going to be negative, 3. Wow, I can't write today. It's going to be 3 comma negative 6. And go ahead and do it with the other ones, okay? And then come back to me. B prime is going to be negative 6 comma negative 4.5. And C prime is going to be 1.5 comma 0. Because 0 times anything is 0, okay? Now this next one's really important, okay? Because we've seen questions like this on the final almost every year. So put a star next to it, okay? So it says RS, triangle RSV has coordinates R, S, and V. A translation maps point R to R prime at negative 4, 8. What is the coordinate for S prime for this translation? So what we're going to do is we're going to figure out what the translation is, okay? So we're going to do our R, which is 2, 1, and we're going to look at our R prime, which it says is negative 4, 8, okay? So what we're going to do is just create an equation and find our x, our change in x, and our change in y. So we're going to go 2 plus x equals negative 4. Okay. We're going to do the same thing with y, and we're going to do 1 plus y equals 8. Okay. So how do we solve this? We're going to subtract 2 from both sides right here. So our x change is going to be negative 6, right? And we're going to subtract 1 here, and so our y change is going to be 7. So now it says do this for point S, okay? So point S, our original point S was 3, 2. So all we're going to do here to find S prime is we're going to go 3 minus 6, comma, and then we're going to do our 2 plus our 7. So that means S prime is going to be 3, comma, 9, okay? So go ahead and try to do the next one and come back to me when you're done. Okay, so this time it's asked us for K. We have K and we have K prime. So K is 2 comma negative 3. K prime is negative 2, negative 1. So here again we're going to go 2 plus x equals negative 2. There's our 2's, right? And we're going to do our 3's, negative 3 plus y equals negative 1. So we're going to go ahead and subtract 2 here. So that means our x is going to be equal to negative 4. Here we're going to add 3 to both sides. So y is going to be equal to 2. Okay, so once again, we're going to do our point L. So L, original L, was 7, 6, right? So we're going to do, for our L prime, we're going to do 7 minus 4 and 6 plus 2. So our L prime is going to end up being 3, comma 8. Okay, so the next one says, if you dilate QRST by a scale factor of 3/2, what statement below is true? So when we dilate, what happens? Sides get bigger, right? But do angles change? No, angles never change. So corresponding sides and angles are proportional? No, because angles do not dilate, right? Okay. Then corresponding sides and angles are congruent? No, because corresponding sides would be proportional. The next one says corresponding angles are proportional. Definitely not. And corresponding sides are congruent? No, they're not going to be congruent because they're going to dilate. Then it says corresponding sides are proportional and corresponding angles are congruent. This is our correct answer right here, okay? Because our sides are going to be proportional and our angles are going to be congruent. All right, this last one on here says the transformation maps ABC to triangle DEF. What do you think happened? Okay, so we're going from this to this. So I can pretty much tell that there was a dilation, right? This was 2, and this is 1. This was 4, and this is now 2. So we know it's a dilation of 1/2. But what else happened? Can you guys tell it reflected? I can too, and let's go ahead and do that. So if we take this point over here on the other side, it would be right there, right? Okay, so then what else happened? it was a reflection, right? So it would have went out that way. Y'all got me? It was a reflection and then a dilation, or a dilation and then a reflection. Doesn't really matter which one happened first here. So it's a reflection over what axis is this? The y-axis, right? And then a dilation by the scale factor of 1/2. That was our answer. All right. Okay, so then for the next one, it says choose the appropriate angle name for the angle pairs given. Choose the correct letter for the angle pair. So 1 and 3, 1 and 3, those form a line. That's a linear pair, right? So this is D. 1 and 5, let me move that mouse. 1 and 5, those are corresponding, aren't they? Okay. Then we've got 1 and 4. 1 and 4, those are vertical angles, aren't they? Okay. Then we've got 1 and 8. 1 and 8. Those are on alternate sides of the transversal and outside our parallel lines, and these are parallel lines, right? So those are alternate exterior, which would be B. Then we got 1 and 7. 1 and 7. Those are same side exterior. Again, outside the parallel lines, right? So same side exterior, that's F. Then we've got 6 and 3. 6 and 3 right there. Alternate sides of the transversal inside the parallel lines. So these are alternate interior. And then 6 and 4. 6 and 4. 6 and 4 are same side interior, aren't they? So same side interior inside the parallel lines on the same side of the transversal. It says which 3 pairs of angles are supplementary. So this is what I told my students, same side supplementary. So they're same side angles, same side interior, and same side exterior. And then what's the third one? The linear pair, right? Because all 3 of these are supplementary. What does supplementary mean? It means when you add them together, they equal 180, right? And then it says what is the relationship of the remaining pairs? They are congruent, right? All the rest of the remaining pairs of angles are congruent, okay? All right, so this next one says, given the following figure, solve for x, okay? So on this figure, we're going to work through the diagram, okay? So the first thing I noticed is we got some parallel lines. So because we got some parallel lines, we can say that this 60 is equal to that. So we know that this angle down here is 60 degrees, right? Now, we also have a linear pair right here, don't we? So these 2 angles, well, actually, let me draw a different way. These 2 angles right here are 180, right? So what is 180 minus 110? That would be 70 degrees, right? Okay. So now that we have 2 of those angles in that triangle, now we could find that exterior angle one of 2 ways. We can add these 2 together, which would be 130, and do 180 minus 130. That would be 50, right? Okay. Well, notice that also when these 2 angles form a straight line. So when we add these 2 together, they also equal that exterior angle, right? So this angle right here is 130. Okay. So that was our answer. 130. All right, the next one, number 18, says find, gives us the measure of A and B, and then it says find X in C and D. So let's just see what the relationship of A and B is first. They form a linear pair, right? So we're going to add them together and set them equal. So we're going to add the measure of angle A plus the measure of angle B and set that equal to 180, right? So we're going to do 3x plus 24 plus 8x minus 9, and that's going to be equal to 180. So 3 and 8x, that's going to be 11x. 24 minus 9 is going to be what? Plus 15 equals 180. Going to subtract the 15 from both sides. So 11x equals 165. Divide both sides by 11. So x is going to be equal to 15. Now we need to plug that back in, right? So what do we know about M? So there's our x, okay? Now we need to find the measure of C. Well, don't we know that C and A are congruent because they're vertical angles? So I'm going to find the measure of angle A, and I'm going to call it the measure of angle C. So the measure of angle C is going to be equal to 3 times our 15, that's 45, plus 24. So the measure of angle C, okay, let's see if I can find this on my paper. Oh, there it is. the measure of angle C is going to be 69. Okay. And then also notice that D and B are the same. So I can find the measure of angle D by finding the measure of angle B. So I'm going to do 8 times 15 here. And I'm going to subtract 9 from that. And that is 111. Whoops. 111 degrees. And notice if I were to add these two together, right, those two, I would get what? 180. And it should be, because they are a linear pair, right? That didn't look like a degree. Okay. So next one says a pair of parallel lines are cut with a transversal. Which statement is true? Alternate interior angles are 40 and 140. No. These would both have to be 40, right? So that's definitely not true. Same side interior angles, 40 and 40. No, because same side interior are supplementary, so this one would have to be 140. So that's not true. Corresponding angles are 40 and 40. I'm proposing that's our correct answer because corresponding angles are congruent. And then vertical angles are 140 and 40. Nope, this one also has to be 140 if that was true. Okay? Okay, this next one says, why are these triangles congruent? So these are our reasons. So let's just look at this one. And I'm suggesting to y'all that you mark these. So this is an angle, and that's an angle, and that's a side, right? So this is going to be angle, angle, side. I'm going to roll this up a little bit so we have some more space, because it's not letting me write right there. So angle, angle, side. Okay, this next one, can't we put 3 ticks on the shared side? So isn't this going to be side, side, side? All right, we can mark our vertical angles here, right? So this is going to be angle, side, angle, right? Okay, again, over here, mark our shared side. And by the way, this was supposed to have a tick there and a tick there, and it didn't. So that's my bad. So this is going to be HL. Why? Because that's our H right there, and this is our leg, right? And it's right triangles. So this one, again, we have a shared side, right? So this is going to be side, angle, side. Side, angle, side. Well, it'd be great if I could write, huh? Side, angle, side. All right, so this next one is our triangle sum proof. And right here we have a bank of answers. It says, given that line J is parallel to K, so we have parallel signs there, prove that angle 1 plus 2 plus 3 is equal to 180. So the first thing is J is parallel to K. That was a given piece of information, right? We were given it up there. Then angles of a straight angle. So don't we have angles of a straight angle right here? So what are those angles? So that's our measure of angle 7 plus our measure of angle 1 plus our measure of angle 4 equals 180, right? So we've used that, and we've used that. Then it says angle 7 is equal to angle 2. 7 is equal to angle 2. Why? Because they're alternate interior angles, right? So we got that one. Then it says there's another pair of alternate interior angles, and there is right here, right? Aren't those also alternate interior angles? So this is going to be the measure of angle 4 is equal to the measure of angle 3. And then why are those 3? Notice that we substituted the 2 for the 7. See that right there? So it was 7 up here. And then we substituted the 3 for the 4 right there. See that? Because of this statement right here. Okay? So this is substitution property. And again, this has been on the final for many years in a row too, so we're trying to make sure you guys are prepared for that. We've done that on tests, but I mean, you know, make sure that you remember it. Okay, so this one, remember, this is exterior angles theorem, right? So we're going to do the angle Y plus angle Z is going to be equal. So we're talking about this angle plus this angle equals that exterior angle. That equals WXY, right? Okay, so that's what we're about to do. 7x plus 8 plus 62 equals 17x. So this is going to be 7x equals 80, or 70, sorry. Wow, can't do, not equals. Plus 70 equals 17x. Subtract the 7x from both sides. So 70 equals 10x, so x equals 7. Okay, but now we got to plug it back in, right? So We're going to plug it in up here. So the measure of angle Y is going to be equal to 7 times 7, that's 49, plus 8. I already did this math. That is 57. So this is 57 degrees, okay. Then we're going to find the measure of WXZ. WXZ is that one out there. So the measure of angle WXZ is going to be equal to 17 times 7. And that's going to be 119 degrees. Okay, so now this is 119, and this was 57. Okay, so how could we find this remaining angle right here? Question mark. So this is the measure of angle YXZ. We could just do 180 minus the 119, right? And that's 61 degrees. 61 degrees. Okay, 23. Hopefully you remember this. If it's an equilateral triangle, it's also an equal angular triangle, right? So all three of these angles would be equal. So we're going to do 180 divided by 3. That's going to be 60. And then it says the measure of angle B is equal to 5x. So we're going to say 60 equals 5x plus 25. We're going to subtract 25 from both sides. So when we do that, we get 35 equals 5x. We're going to divide both sides by 5. So x is equal to 7 here. Okay. So the next one, again, this is an isosceles triangle, right? So we know that the base angles are the same. So it says x is 67, so that means y is, or z is 67. So how would we find this one? We would add 67 plus 67. That's going to be 134. But then we're going to subtract that from 180, right? Because when we add up all of them, they should equal 180. So that's going to give us 46 degrees for our top angle up there. Okay, now the next one says to find the value of x using the triangle sum theorem. Okay, well, yes, but don't we know if 90 is used? We only have 90 left, right? So when I add these two together, don't they have to equal 90? Exactly. So x plus 4x is 5x plus 5. That equals 90. Subtract the 5 from both sides. So that's 5x equals 85. Divide both sides by 5. So x is going to be equal to 17. All right, the next one says in the diagram, actually let me pull this up so we can see the whole thing. In the diagram, lines M and N are parallel, so we're going to go put some parallel symbols on them, okay? Find x in the angles where x, the x's are. What is the value of x, okay? So first of all, don't we notice these form a line? So we know that when we do 6x plus 3x, it equals 180, right? So that's 9x equals 180. Divide both sides by 9. So x is going to be equal to 20 here, right? So x is equal to 20. And then it says find the measure of w. Okay, so I noticed that I got this 35-degree angle up here, and it should be congruent with this angle down here, shouldn't it? Why? Because they are alternate, what? Exterior angles, aren't they? So this is also going to be 35 degrees. So obviously it's not that one and that one. It's either B or it's D. So it says 31 is 35 because alternate exterior angles are congruent. They're not corresponding, so it is B. Okay?